Next, we will discuss the concept of this LOD, which is a level of development, and that applies to all types of BIM models that can be created in the VDC enabled project. All right. So like I say, the architect will create his own model. Okay, the structural engineer can create his own model. The M&E services engineers, they also create their models. But at different phases of the project life cycle, the amount of information that you want to put into the model, okay, need not always be 100% complete or 100% detailed, because that may not be needed at that particular stage. So that is why we make use of this concept called level of development to tell all the different stakeholders how much detail we are actually putting in. Just to give you an example, so during the initial feasibility study or the conceptualization stage, the structural engineers, let's say BIM model, for example, if there is, okay, he wouldn't go into the detail on the types of bolts that he's going to use to connect, okay, let's say a joint between a beam to a column at a certain location. He will just indicate that that particular location is going to be a steel component, and there's going to be, for example, a fabricated joint instead of welding. All right. So the amount of information that you want to put inside the model during that initial stage wouldn't be so detailed as to specify the type of bolt, the size of the openings for the bolt, the nuts, okay, or even if you are doing welding, what type of weld, okay, the dimensions of the weld. But as you go along the project, okay, when it goes to the design phase and it goes to the construction phase, you'll find that there will be a need to put in all this information in the time to come. So your LOD level, okay, will actually change, okay, as you go along the different phases of the project. All right. So having a definition or the concept of LOD allows the stakeholder to be able to more meaningfully exchange information. All right. So the level of development or LOD will define the content that we put into our BIM model, or the geometric information, for example, the length, the breadth, the depth, the thickness, that sort of information, or structured data, whether is it going to be like fire rated to 3 hours, what type of material, so on and so forth, okay, as well as any other documentation which is not a geometric information that we want to link to our model, okay. So the reliability of the BIM elements at the different stages, also we want to discuss about that, okay, or indicate that in our this LOD, okay, so that people can understand, okay, what to use the model for. All right. So each LOD class defines its usability and limitation of the model element, in the BIM model. There are several systems to classify the LOD in models, different standards to adhere to depending on the geographical locations or the reference institution. Mainly there are two types, okay. Or there is the US version, okay. There is the UK version, okay. So there are two different versions, okay. So when we talk about, for example, level of details, basically what we are talking about is that we want to know what it looks like, okay. So level of details basically look at the specific steel shapes, okay, to ensure that the location can be measured precisely. But if we are talking about level of development, we are basically asking ourselves how much has the model been thought through, okay, meaning that have the shapes been properly engineered and designed, okay, or are they in their final location. So just now we were saying that there are two different standards, the US standard and the UK standard. If you are talking about the US standard, basically they take the level of detail plus the level of information to come up with the concept of the level of development. Whereas for UK, they also take the level of detail plus the level of information and then they use this concept called the level of model definition. Okay, so in a sense, sometimes the US the consultants, they call it LOD, but for the UK consultants, they call it the LOMD. Okay, but they are all talking about the same concept, which is how much information has been put into the model. Let's look at the US version first. The US, they call it the LOD. Okay, so the this concept, okay, it provides an industry developed standard to describe the state of development of various system assemblies and components within a BIM model. So in the US LOD system, they are altogether, different categories: LOD 100, 200, 300, 350, 400, and 500. So if your model is going to be at LOD 100, that is the lowest level, meaning that the amount of information that you want to put into your model can be as such. Okay, your model element, okay, graphically represented in the model with a symbol or some general representation, but it doesn't satisfy the requirements for LOD 200, which I'll show you later. Okay, information related to the model element, okay, can be derived from other model elements. And typically LOD 100, the type of a model, what do we use it for? Okay, well, we use it for concept design. Okay, concept design. So the building 3D model is developed to represent the information on a very basic level. Okay, so thereby only concept design model is possible in this stage. Parameters like the height, the volume, the location, the area, or the orientation, they are defined. But you don't go into anything more detailed than that. So this one is the LOD 100. When you go into specifying LOD 200 for your model, the amount of information that you want to put in will be in fact more than LOD 100. So the information or the model element needs to be again also graphically represented within the model as a generic system, okay, or object or assembly, but now with approximate quantities: the size, the shape, the location, and the orientation. And on top of that, non-graphical information may also be attached to your model element. So you can see that if you compare between a BIM model that is at LOD 200, it will incorporate more information compared to a BIM model that is at LOD 100. Alright? And therefore, the LOD 200 is much better for a schematic design. It is still a general model, okay, where the elements are modeled now with more approximate quantities: the size, the location, the shape, and the orientation. And as mentioned, we can attach this non-geometrical information to the model elements. So when you go on to LOD 300, your element that you want to model, okay, will be graphically represented into the model now as a specific system or object or assembly in terms of the quantity, the size, the shape, and the location and orientation. Okay, and again, you can also attach non-graphical information into your this element in the model. Okay, so now it's a more detailed in a sense that it is a specific, okay, or specific system compared to LOD 200, which is a generic system. And therefore, any model with a level of LOD 300 should be used, okay, or be able to be used for detailed design. So when you specify a model to a standard of LOD 300, okay, you are allowing for accurate modeling, okay, and shop drawings, okay, to be developed, where the elements are defined with a specific assembly, precise quantity, shape, size, location, and orientation. Yeah, so that is LOD 300. In the US system, they actually allow for another increased level of detail, okay, or between the 300 and 400, they call it LOD 350. Yeah, So if you model your this beam model to a detail of 350, the model element will be graphically represented as a model, within the model as a specific system object or assembly. Again, in terms of quantity, size, shape, and orientation. And now, okay, it will interface with other building systems. Okay, the keyword is that compared to LD 300, okay, if it's LD 350, it will show, okay, the interface with other building system. Okay, all right. And just like LD 300, you can attach non-graphical information, right? So for model to the detailed this level of LD 350, it is typically for construction documentation, or where it includes model detail and elements that represent how the building elements interface with the various systems and how other building elements with graphics, and these are written definitions. So that is LOD 350. The next level will be LOD 400. Where again your model element is graphically represented within the model. Okay, yeah. And now, okay, there is enough information about your these individual elements that make up your model to allow for fabrication. Okay, or detailing, fabrication, assembly, installation information. So that is for LD 400. So for fabrication and assembly, the model elements are modeled as specific assemblies with complete fabrication, assembly, detailing information, in addition to a precise quantity, size, shape, location, and orientation. Okay, so that's LOD 400. The highest level will be LOD 500 in the US system, where your model element is a field verified representation in terms of the size, shape, location, quantity, and orientation. So in a way, it is what we call SPUE. Okay, it's SPUE, right? SPUE. So the elements are modeled as constructed assembly for maintenance and operation purpose. Okay, so in addition to actual and accuracy in sizes, shape, location, quantity, orientation, non-geometric information, they are also attached to the model element for the purposes of this operation and maintenance. So that is the US this standard in terms of the amount of detail that you put into a beam model. Okay, so they have LD 100 to 200 to 300 to 350 to 400 and finally to 500. 6 levels of detailness in a sense. Okay. The UK this system is a little bit different, which we'll also talk about next.